So we'll continue with the question. Now, the wording of this question, and I was talking to Alif a minute ago, the wording of the question is a little bit strange here. They say, or he says, in D, do it in the direction of angle pi over 4 with the gradient. It's usually with a certain axis that we work with. When he says with the gradient, I don't really know exactly what he means with the gradient. So I'll do it normally. So if you can double check with the prof, that would be actually good. So again, we need a vector of cosine and sine. The angle is pi over 4. Cosine pi over 4 is 1 root 2. And this one is 1 root 2. And then we do the cross multiplication. 2 and minus root 2. 1 over root 2. 1 over root 2. This times first is 2 over root 2. And this times this would be 2 over root 2. They cancel each other. The derivative here is 0. But again, I don't know when he says the angle with the gradient, and I couldn't find it even in the textbook or anywhere, so I don't know. Question E. And again, this is strange. In the direction along the tangent vector to the level curve when f of xy equals 1. Okay. Again, I mean, I don't know what he means when he throws the tangent vector here. But this is how I would approach it. Again, both D and E, if you can double check, if you can send him the answer, say, am I right on the right track? Do I need to change? Double check. So what I think you're supposed to do is, you say, I'm going to take the actual function and make it 1. This can only be 1 if the exponent is 0. So if you bring y over, and then you cancel y from both sides, then x equals y. So that means that the vector is a number and it's the same number because both x and y are the same. So you can treat the vector as use vector AA. I'm gonna erase some of this. We get the unit vector of this, so we get, let's call this vector V now, AA. Let's do the same thing we did for the first question. The unit vector, so we go V over the magnitude of V. A, the magnitude, as you guys know, square root, the first one squared, second one squared. So it's V over magnitude. This is A, comma A. This is 2A squared. So square root of 2A squared and square root of 2A squared. Now, the square root of 2 is square root of 2, and the square root of A squared is A. And here, square root of 2 is square root of 2, and the square root of A squared is A. Cancel, 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 cancel. So you're actually doing 1 over root 2, 1 over root 2. So I'm gonna do this, which is similar, like D and E ended up the same answer. 2 minus 2, 1 over root 2, 1 over root 2. This times the first, second times second, answer would be 0. But again, the language is changed, it's different. So the fact that he said the angle with the gradient in part D, and the fact that he wants a tangent. So if you could double check, and if he responds to you, you can send it to me and I'll understand exactly from his answer what he's trying to do. Okay, we'll continue with this. We go to question number 4. Question number 4. In question number 4, you have a function in terms of x, y, and z. It's x, y, tan inverse of z plus z sine of xy where x equals uv, y equals u squared, and z equals e to the uv. And then he wants to find f, the derivative of this in terms of u. This is how you apply the chain rule, basically. To do the derivative in terms of u, you do the derivative with respect to x times the derivative of x with respect to u. So if you see, basically, these two cancel, so I'm finding the derivative with respect to u. And then you go, derivative of this with respect to y, and then dy over du. So again, it's the derivative with respect to u. And finally, the derivative with respect to z, dz over du. Then you start finding the derivative. The derivative of this with respect to x, so everything else is a constant. The derivative of this with respect to x, this whole thing will be a constant, so the answer would be y tan inverse of z, and the derivative of x with respect to u. We find the derivative of this in terms of u. A constant u would be just a constant. So this is the derivative, the first term. Derivative of this is the second part. So we did the derivative of this with respect to x. Now we do the derivative of this with respect to x. Everything other than x is a constant, so the derivative of this with respect to x would be cosine xy, and the derivative of xy would be y with the other constant z. This whole thing is the derivative of the function in terms of x. And the derivative of this in terms of u would be v. That's the first one. We go to the second one. The derivative of this with respect to y, everything else is a constant, so it would be x tan inverse of z. Derivative of this with respect to y would be zx cosine xy. This is the derivative of this function in terms of y. And the derivative of this derivative of y in terms of u would be 2u. Finally, we found the derivative with respect to z. The derivative with respect to z would be This is constant. The derivative of tan inverse would be 1 plus the inside squared and the constant xy. The derivative of this, a constant z, would be the constant, which is the sine of xy. This is the derivative of the function in terms of z times the derivative of z in terms of u. So the derivative of this would be itself times the derivative of the exponent, and a uv has a derivative of v. So this here is the derivative of the function in terms of u. Hopefully you can see it. It's not bad, but it's just a lot of steps. You also need to find the derivative of this in terms of v. That would be in my next video, part 3. Before we go to part 3, you could actually try and simplify this, but I think it doesn't say in the question simplify or not, but I don't think that you need to. I think he expects the answer to be in this form. Simplifying this would be a lot of steps that you need to do. So I don't think you need to simplify. So I would leave it the way it is. Okay.